Hey everybody, it is Wednesday the 13th or Thursday the 14th, depending on which day you have us, and here's our do now. How many hydrogen atoms are there in 3H2SO4? So right now we're only concerned with the hydrogen right here, the little friend right here, and so 3, because that's the coefficient, we multiply times everything, but I only multiply times the 2 here for the subscript, so 3 times 2 is 6. How many total atoms are in the product of this equation? Number 2, we have to figure out what's where. So remember, on the left side here, that is our reactants. The arrow is where the reaction occurs or takes place and gives us a yield of these products. So I want to know total atoms. I have 2 sodium, 1 sulfur, that's 3, plus 4 oxygen, that's 7, 8, 9 hydrogen, and 10 atoms total for the product this side right here. So that would be right this group of friends right here, and we're going to highlight that so everybody can see that. That's our product. Oh, sorry, I did not highlight that. I thought we did. Okay, there we go. Oh, it's not doing it. All right, that's all right. So it's right there, though. All right, so then our next question, some star-like questions for today were, which chemical reaction involves the fewest oxygen atoms? So you're going to go through and again, count the oxygen atoms all the way through. So 2 times 3 is 6. That's 4 more. That's 10. 4 more is 14. And 2 times 3 is 6, and that's 20. So you're going to go through all of these. And once you do that, you will find the answer. Yep, and for my friends who figured it out, it is actually J, because 3 times 2 is 6. 2 times 2 is 4. That's 10. And 2 times 1 is 2. That's 12. So these were 12, and these were much higher than that. The chemical formula here in 31 for sodium sulfate is Na2SO4. How many sulfur atoms? So just the S. Remember, in science, on the periodic table, elements come in 1 capital or 1 capital and 1 lowercase. So these are 2 separate atoms. So if I had my periodic table, I look and there's my S for sulfur, and I only have 1 because there's no subscript and it's just there. And then lastly, which of these formulas contain equal numbers of nitrogen? So if you go through and you figure this all out and you take care of the subscripts. Now, subscripts with parentheses are different. That means I multiply that 2 times everything inside. So I have 2 there, 2 there, 3 there, 3 more there, and then I have 1, 2. So I have groups 1, 2, and 5 all have 2. Okay. So here is, I will practice counting atoms and determine if chemical equations are balanced. I will determine if the chemical equations show mass being conserved. What that means is that we have the same amount of elements in their atomic form on the left side as we do the right. I can identify reactants and products in chemical equations. We just did that. I can count the atoms. We just did that. I can play games to help me understand what makes them up, and I can tell the difference between physical and chemical reactions. We're a little friend here, though. So, all right, everybody, sorry for that. I had to take a quick break. I got a call. All right, so wrap, reactants, arrows, and products. I'm just reviewing the slide from your notebook where we dragged and dropped all these. Just remember that reactants are on the left side. The arrow indicates the reaction or the yield. That's Y-I-E-L-D, like a yield sign, because something happens. And then we have our products, the thing that's produced. All right, so we want to ask, where are the products? Are they at the beginning, the arrow, everything to the left, or everything to the right? And it is everything to the right. All right, and our next slide here is it balanced? So what we're doing is we're going to write here, and we're going to do a little demo here. So I'm going to work the first one through with you. So what I'm going to do, excuse me, is do 2 columns do 2 sets. Because I've got to make sure, let's see, put a plus sign, and we'll put a, let's see. So I put a bar in here. There we go. So how many N's do I have on the left side? There's my equal sign. I have 2, because that's what the subscript says. How many nitrogens do I have on the right side? 2, because that's what my subscript says. All right, So let's do the oxygens. Oxygen equals, oxygen equals, and on this side the little subscript here says 2. We're going to put a little symbol there so we don't get confused. And on this side I have oxygen and it equals 5. So here's what I'm saying. When I do the counting, is it balanced? Well, I have 2 nitrogen, I have 2 of the same, I have everything here, but I have more oxygen. So it is not balanced, and so the law of conservation of mass says it is also, we are not conserving mass, because we should have the same number, 2 and 2, 2 and 2, not 2 and 5, and the same symbols. So that's there. So we're going to talk a little bit about the difference between chemical and physical reactions. You're going to need to locate this video, and it's 13-14 in your daily slides. Let me show you where that is. Let's just pick on our friends here in first period. All right, materials, and we would find that in our materials. And the 14th, right here, the slides are right there. You would need those because some of the embedded videos that we're going to look at are not available. So this is slide. So here are some physical changes, and you can copy and paste this definition right into slide number 20. So you want to have 2 tabs open, the definition and an example. So we're going to do that right now. So here is, we're going to copy that. We're going to come to slide 20 in our digital notebook, and we're going to hit Control-Shift-V, and it will, wrong thing. Didn't copy over correctly. So let's do that. So, okay. Control-C. Come back here and go Control-Shift-V. All right, see, there we go. And then here on chemical changes, we're going to find that. But here are some examples. That crushing a can, that melting an ice cube. So what we'll do is, let's put in crushing can, melting ice, and I'm going to add another one, boiling water. So we take that through the, well, my typing's really bad today. So we take it through all the stages. And here you're going to find a picture of a physical change. All right, and then we're going to come down to the next slide. And again, you can just copy these directly from the slides in your notebook. We're going to copy that. So we're going to hit Control-C, come back to slide 20 in our digital notebook, and Control-V. Oop, I didn't do that right. See, so here's what happens when you don't do it right. Okay, backspace all that. Control-Shift-V. Ooh, okay. Well, I didn't do that right. So let's change the color. And we'll change the size a little bit. All right. And I'm going to shift that over just a hair. All right. So chemical changes, and here's a slide, are things like an iron rusting, cooking an egg, because you're taking it from one to be another product. Electroplating a rotting banana, fireworks, because once you blow those little guys up, you can't change that chemical reaction. So here, let's put in the cooking an egg, because you change the proteins, and that actually changes the substance. We'll say fireworks, because again, can't put it back together. Okay, I could actually take this can and really iron it out. I could not take a firework once it's been exploded. So you want to make sure you find pictures on Google for your notebook. And then here is a, you're going to watch this video in the slides. Tell me, is it a chemical or a physical reaction? And we're going to help you that it's chemical. And I want you to think about what you observed that makes us think that it's that. And the reason I say that is that here are the signs of chemical change. We get a change in color when it's unexpected. So maybe you're mixing 2 clear things and all of a sudden you get purple. When you gas, bubbles forming, light is produced, so like a flame. Change in temperature, hotter or colder. A precipitate forms, or a change in odor. So this is in your slide 22 in your digital notebook. You'll want to drag and drop the colors, the letters here to match. The acronym we use is City Girls Like Their Phones, and then the odors. So remember, chemical changes are gas, like Alka-Seltzer, rusting, temperature change, precipitate. So what this shows is that they were two clear liquids. One was dropped in, and when it hit this one, it formed this yellow stuff. And if you watch that slide, the little time lapse there, you can actually see that happening. And there are some great videos here. We can watch a gas form in elephant's toothpaste. You can watch Steve Spangler talking about color changing, and that's really cool. You just need to click on these in the daily slides because they won't show up in here. The Rotten Egg Lab, change in temperature, flammable water, golden rain. So if you notice here, they're pouring the clear liquid, two clears. We're getting this yellow precipitate. There's the surprise fire. And key points is that chemical changes make new substances, the property changes. So I even tell as we're talking about this, when you're making bread, you're going to mix flour and yeast and water together, and you're going to mix it up and you're going to get this goopy stuff, and then you're going to pop it in the oven and you're going to get bread. But can I take that bread and take that bread apart and make that bread back into flour and yeast and water? And the answer is no. Okay, and so then you're going to take these, you're going to drag and drop. So we did some of these together. We said you can follow along, try and figure out the slides above here will help you figure that out. If you look back here, chemical and physical are all grouped there. And then there's a, and that's where we're at. So sorry you couldn't be with us today, but we'll see you tomorrow.